Alright, well, welcome back. This is part 2 of this vector sum function. The vector sum function video. Alright, so, let's just write list sum out real quick. Alright, list sum, of course, just does a list 2, 3, 4, and it returns 10. Alright, define list sum lambda ls if null ls then 0, otherwise plus car of ls to the coda of ls. Alright, this is pretty standard flat recursion function. Let's comment that out and run it. Oops. Comment that. Comment those. Alright, so list sum 1, 2, 3, 4. Oh, right. No, that's wrong. Okay, so list sum, and we list sum the coda of ls. Alright, so we got, I forgot the recursion there. Okay, so run that. List sum 1, 2, 3, 4, 10. Alright, that's what we wanted. So with list sum, you see, we add the car onto the list sum of the coda of ls. So likewise with the vector sum, we're going to add the whatever the index is at the time. So we're going to start at 0. So the first one in the vector, which is 0, we'll start at 0. And that will give us this first number here, and then we'll add that number to the vector sum at the next index. Alright, so so on the list we stop when the list gets to null, and that's because each time we keep running list sum on the coda of ls, so it shrinks each time. But on the vector there's no coda function, so it doesn't shrink, but our index that we're keeping track of will keep moving one step closer to the end here. And how do we know that it's at the end? How do we know that it's the last one, or past the last one? And that will be when it reaches the length of the vector. So we've got to have know the length of the vector, which we can get with vector length, the vector length function. Okay, so let's so in order to have an index that goes and keeps track of where we're at, we've got to have another variable in here, but instead of adding a variable, like you could just make it so that the user has to add in a variable 0 and then every time, but we don't want to have to make the user do that. So let's just define a helping procedure that does it for us. So let rec, because letrec can do recursive functions, helper lambda we don't need to take v, we just need the index I. Okay, so let's do our stopping case. If equals I vector length v, then what do we want to do? Well, we want to return 0, just like in list sum, because that's going to be the last thing. We don't want it to affect the operation that's going on there. Alright, then otherwise we'll plus the so index there, the vector ref of the vector at index I. So so let's see, vector ref v at index I. So we grab that one, and now we want to add that to the not the vector sum again, just the helper of the next index up. So the vector the index plus 1. Alright, let's try this. Uh-oh. No expression in body. What? that? Oh, right. Okay, so you'll notice in vector sum here we're not actually calling helper at all, so that's sort of a problem. So we've got to make sure we call it with 0 as the starting index. Okay, now let's run this. Vector sum vector sum yes, a vector. We've got to give it a vector. 1, 2, 3, 4. Alright, and we get 10. That's great, just what we wanted. So let's try running vector sum without that quote and see if it'll work. I don't know if it will or not. Yeah, it works. Alright, so sometimes I have noticed that it doesn't work all the time if you don't have that quote. I think actually in on the auto grading program you need to have a quote for some things, but since you're not going to be asking the questions, you don't need the quote when you're testing it out. Alright, so let's we got that. Now there's something slightly inefficient in this program, and this is vector length function. We have to call vector length a bunch of times, and I'm not actually sure how vector length determines the length of the vector. I don't think it's like list length where it has to go down the entire list and count. I think it probably just knows, so that's not that bad, not much of a waste. But if you wanted to make it maybe slightly faster, you could put a let right here, right in that spot there, and let like vector length VLAN equal vector length of v, and then instead of writing vector length v, just refer to VLAN. But we don't have to be that efficient, since this isn't like production programming or anything. Alright, so let's make a function next called vector2list. We'll leave vector sum up there, we can just modify it. Alright, so vector2list. It'll take a vector like 1, 2, 3, 4, and it will return a list with the same elements in it. Alright, so let's see if we can so basically we'll just have an index that goes through here just like we did on vector sum, but instead of adding each number to the next number, you can cons each number onto the next number, and once you get to the end, instead of putting a 0 out, put out an empty list, and then you'll have consed all these numbers into the empty list, so basically you'll end up with a list of it. So let's just modify this vector sum here, call it vector, well we have to call it something else, we'll call it iVector2list, because we don't want to accidentally overwrite the real vector2list function. Okay, then let's see, we'll put that to be the empty list, and we'll just change that to cons. Alright, and run it. Okay, iVector2list of a vector 1, oops, 2, 3, 4. Alright, so we got a list 1, 2, 3, 4, just like we wanted. Okay, on the opposite way, oh yes, the next video I'll show you 2 more special functions. One will be list to vector and the other will be vector map.